Hey guys, had a chance to start using the rotary option in Aspire 9.5. Learned a few things, so I thought I'd make a quick video to pass along what I've learned. This will be kind of 4 parts to this video. Number 1, we'll go in and do some very quick modeling work in Aspire 9.5. Only be modeling the part where we take a rectangular stock and turn it round. So that'll be a very quick part of the video. And then we're going to go into the 3 ways that you can turn it round. One of them is radial. That will be making cuts in this direction. The other one is raster. Raster will be making cuts in this direction. And then the third one is an optimized raster. And optimized raster is going to realize that this is square stock. And we're going to cut the corners off first, and then we'll come down and make the final cut to get to the diameter that we wanted. So, pretty quick video. In the course of it, I'll pass along, oh, well, that's something I learned, that wasn't what I expected, and some things like that. Hopefully that'll be of value to you. In this section of the video, we're going to do our quick little modeling. I'm going to bring up the Aspire 9.5, and as I'm recording this, I just noticed that there is a new version of Aspire that is out. I am using 9508, which could be very important if you're looking at this video later on. Some of the things that I point out may have changed. So I'm using 9.508, 9.509 is available at this time. So we're going to start by creating a new file, and we are going to select the rotary option right here. And here is where we put in the job size. The piece of material that I have is about 3 inches square, and it is 12 inches long. Now, this is actually the first place that I ran into something that wasn't quite like I was thinking it should be, but as I thought about it a little bit more, it's probably the right solution. So the length is 12 inches, that's correct. I'm going to make this 2.875. The key thing here is the job size you're putting in is the size of the blank after you have rounded it. In this case, I'm going to just take the corners off, and I'll take about 1/8 of an inch off just to get everything nice and round. So 2 7/8 will be my finished diameter of the part. We'll get to in a minute. How do we put in the size of the blank that I'm starting off with? The rest of this, probably kind of straightforward, or you can see it from other videos that are on the web. Your preference should be to use the cylinder axis rather than the cylinder surface. I'm putting the XY datum in the lower left corner, and on the machine that I've got, Maverick 3x5, they go along the x-axis, and we will say OK. Now, it's created the blank for us, and it has done a couple of other things that for right now, for this video, aren't going to be something that will come into play, but I will just point them out for future reference. If we go over to the Layers tab, you'll see it's created a 0 plane, it's created a layer 1, a 2-rail sweep, and a bounding box. You may or may not need those for your project. You can delete the ones that you don't need. In later videos, we'll come in and be using these, but for right now, just be aware that they got created for you. So we're going to go back to the drawing tab, and now we're going to come up to the gadget, wrapping, creating round toolpath. This will be the extent to which we kind of do modeling for this video,
and then we'll get into more modeling in other videos. So here is where you define the size of the blank that you're starting with and kind of the geometry of the blank. In my case, I've got something that is square. It's about 3 inches. You could also be starting with a blank that has some kind of a diameter. It's close to being round, or it's round. If you're doing that, then you're going to put the diameter of that in here. The key thing is, down at the bottom, this is what it's going to take the part down, the blank, down to. So in this case, the diameter that it's going to cut down to is 2 7/8 of an inch. So we're going to do each one of these machining methods. We will start with radial, and that's going to be just, as I mentioned in the introduction, it's just going to be going around and around the part, taking it all the way down to the 2 7/8 inch diameter. Next, you can select the cutter that you want to use. I'm going to hit the select, and the tools will come up. Now here's the second place that I ran into something that I didn't quite expect. So if you come up to typically I would use an 1¼ inch surface planing bit to do this, and if you come up and you click on that, notice, no, come back here. It didn't like the fact that I was trying to use a surface planing bit. It will only accept end mills. So I've got a 1/2 inch end mill. I selected that, and I'm using only an 1/8 of an inch cut depth. That's probably a little conservative, but there's a reason behind that. I won't go into those reasons. I haven't quite figured them all out yet. So I was going a little bit conservative here on the way that I cut this. 40%, the rest of these are about what you would expect. Now, this is going to be important because we're going to talk a little bit about some of the timing it takes. It's possible that the timing is, don't put too much weight on that, because if we were cutting a little deeper, then of course it wouldn't take quite so long. So we've selected the cutter. We're going to say OK. Now we can name the tool path. It's going to generate a tool path for us, and we will name this radial, and we are going to say OK. Now what it's done is it has created the tool path over here using the name that we gave it in the previous window. So we can click on this, and here's the next thing that came up that was a little surprising to me. Notice this cut depth. That cut depth is, I'm not sure where that's coming from. However, I looked at the G code. The G code is cutting to the correct depth, so I just ignored this. If you try to make some kind of a change here, for example, you want to go in and edit the tool, then when you try to save out of this, it's going to say, hey, you're cutting through the part. Normal error message comes up. And so far, I've been successful at being able to ignore that. We're going to stay with the defaults that we got here. And so we're just going to hit close. Now, that's the first tool path that we want to use. Okay, now we're going to come back to the gadget again, wrapping, create a rounding tool path, and we're going to come down here and we're going to say rounding tool path raster, and we will say OK. Now we've got the raster one. We will do the same thing again, wrapping, create rounding tool path. And this time we're going to have an optimized raster. And we'll use the same cutter. We're going to say OK. All right, now we've got our 3 tool paths. We will make a individual file of each one of these. In other words, we're going to say save tool path. I am going to only save one of these. And make sure you've got the 4-axis. This is doing the turning center, so make sure you've got the correct post processor selected, and then we'll hit save toolpath. We'll do that for all 3 of these. I'm not going to go through those steps here, and we'll create the G-code files that we want to take out to the machine. Okay, so next we'll go out to the machine and we will cut each one of these and talk a little bit about the differences that we saw as we were doing the cutting. In this example, we're using the radial cut. I'm starting this sort of in the middle, or after it had done the first pass. The first pass didn't have much that it was cutting off, so kind of skipped over that one. You can see that the way it cuts is it'll cut 360 degrees in one direction, move the bit, cut 360 degrees in the other direction, turn around and keep repeating that until it gets to the end. We'll let this go at normal speed for just a little bit here to kind of give you an idea of the way that it's doing the cuts, and then we'll speed it up. And I want to point out one other thing that I found with this, with the way actually all of these different models of turning something around cut. So we'll let this guy go just a little bit longer, and then go into a 10x speed and even skip to the end of the cut. Let the bit go down, and we'll cover an additional item right there. Okay, this is 10x speed, and then we're gonna skip to the end. Now, the thing I want you to look at on the end, it was a little bit of a surprise to me, is the bit actually, the G code actually takes the bit to the 0 position. What that means is that in my case, I've got a 1/2 inch diameter bit. That means a 1/4 inch of the bit is hanging over the end of the material on both ends. Now, in my case, that didn't cause any real problem because the diameter of my material was large enough that it wouldn't be hitting tailstock or headstock, and I wasn't using like a chuck or anything like that. If you're using something that can't accommodate the bit going past the end of the material, then you're going to have to be careful with that. This may be another reason why using that 1.25" surface planing bit might not be a good idea. In that case, you know, you're going to have more of the bit hanging over the end of the material. So it kind of feels like a mistake to me, but that is what the G code was actually doing. Okay, that completes it. I've speeded this up quite a bit. The whole runtime on this was about 1 hour and 25 minutes. I'm only pointing that out because I want to look at the relative runtime of all 3 of these models. Don't put too much weight on the fact that this took that amount of time, because we're only taking 1/8 of an inch off on each pass. In this example, we're doing the raster cut. Notice right here at the first, it spins the part. Not quite sure why that happens. Didn't check the A-axis setting on Mach 3 when I started this, it could be that it's returning it to A0. But anyway, the part spun on me when I first started. You're going to see that spin also at the end, so that's why I'm kind of guessing that it's going back to an A0 setting, but I can't confirm that. So what's happening here is it's just going back and forth, taking off the corners as it is trying to get the part down to round. And you'll notice that there is a lot of time that is just cutting air. So obviously that's where the optimized cut that we're going to get to next comes into play. We'll let this guy go at normal speed, and then we're going to speed him up and jump to the times when it actually makes a cut. It's going to do this, times when it actually turns from one direction to the other. This is going to do similar to what the last cut did. It will go all the way around 360 degrees, move the bit down, and then start rotating back in the next direction. Rather than kind of put you to sleep with this cutter head going back and forth, we'll get to a point right here where we jump down to the, there we go, we jump down to the next direction, and then we'll just cut a little bit here and be skipping to the start of the next cut. Won't go through that whole cut, but skip back to the following cut, and then do a bunch of skipping around here until we get down to the final cut. And right at the end here, when we get to the final cut, you'll see the part spin. Since I'm going at 10x, it'll move kind of fast, but that's why I'm thinking that the part is right there, spun back. So I'm guessing that is returning the A axis to the 0 position, but I didn't confirm that in Mach 3. This whole cut took about 41 minutes, so it's a little faster than what we had before. We'll move next to the optimized cut and see if it is any faster. This method is called optimized raster, and it has one thing we have to do at the start. We have to zero out the A axis, meaning that I've got to adjust this so that the part in the turning center is set to 0 degrees. What this will do, as we've mentioned before, is it's going to turn the part 45 degrees, take the first corner off, turn another 90 degrees, take the second one off, and so forth. So, first step, put your little gauge on the stock and get it pretty close to 0. And then we have to go over to Mach 3, and we'll see that coming up in just a bit here. We'll go over to Mach 3, and we're going to reset A back to 0. Now, we're ready to start. We can see it turn 45 degrees. It's going to start taking that edge off. It'll go back and forth, then turn back, go down a little bit more, take a little bit more off. This pass, this set of passes, I guess I should say, will go down to the 3-inch diameter, or 3-inch distance that we defined for the square stock that we started with. Remember, the diameter that we want to get to is 2 7/8. So at the end of this, you're going to see that it does one final pass where it takes the part down to 2 7/8. So it's got a few more passes to go before it gets this one corner down. We'll let it do this at normal speed, and then we will speed it up and take the other 3 corners and the final pass at the faster speed. Okay, this should be start of the final pass for this first corner. Now that should have the first corner rounded off. We'll bounce up to the next corner and go to a 10x speed, and we'll take these other 3 corners down, and then I'll point out when we get to the final pass here. Second corner's done. We start the third corner. Now we're ready to start the last corner. And now we've got it down so that it's 3 inches. We're going to take the last 1/8 of an inch off and go all the way around the part, cutting as we go. And then we'll be about done. So, to kind of summarize the amount of time each one of them took, the radial, the first one we did, took about 1 hour and 25 minutes. The second one, the raster, took about 41 minutes, and this optimized raster was about 20 minutes. So, again, I'm going to emphasize that the amount of time is probably not too accurate here, but hopefully the relative difference between the times is something that could be significant. So that kind of concludes this video. Hope it was helpful to you. Hope you had a chance to learn something about turning round in the new version of Aspire. Thank you for listening.